and welcome back to another stream. And I was not able to solve the lead code contest number 505, but I'm trying to solve it virtually. So I'm targeting to solve one or two questions from this contest. So let's start. Okay, I haven't seen any questions from today's contest, so I'll be taking them as fresh questions and then discussing the intuitions behind it, and then the actual code for the question. So let's read the question. Question number one, sum of the compatible numbers in range one. You are given two integers n and k. A positive integer x is called compatible if it satisfies both the following conditions. Okay. So if absolute value of n minus x is less than equals to k, and the second is n x is equal to 0. Okay. So return the sum of all compatible integers x. Okay. N denotes bit by end and absolute difference. Okay. Nice. So let's try run this question on a particular test case. Okay. So for n is equals to 2 and k is equals to 3, what we have to find, we have to return the sum of all compatible number. And the rules for the compatible number is rule for compatible number. Uh, Absolute value of n minus x is less than equals to k. This is the first rule. The second one is and x equals to 0. So it's a bitwise AND operator. So we have to AND n with x, and that should be equals to 0. Okay, it means the bit is not set. Okay, so we have to return all the compatible numbers. Let us take the dry run example. For n is equals to 2 and k is equal to 3, the compatible integers are x is equals to 1, because absolute value of 2 minus 1 is equals to 1, and 2 and 1 equal to 0. Okay. What is the range for the numbers? The range for the number is between 1 to 100, and the range for k is between 1 to 100. So we can try the brute force approach here. Okay. The main thing is how to decide the range for calculations. A positive integer x is called compatible if it's satisfy both the conditions. Okay. Okay. So first we have to figure out we have to figure out first we have to figure out range. And for finding that, let's consider that absolute value of n minus x equal is less than equals to k. Okay. So considering x as a positive number, the n minus x is always positive in this case. Okay. N minus x is always positive in this case because we are taking absolute value. So what will be the value of x? The value of x will be less than equals to k. So this is the final value of x. And one more case, there are two cases. If the absolute value of n minus x is less than 0, it means n is less than 0. It means n is uh, less than x. this is the only case where we will get negative values. Okay, so we have to handle both the cases in this question. Okay. Mm, okay. So let's derive the range of x for both the values. So what we'll do, uh, for example, the n minus k, n minus x is positive. In this case, the value of x will be n minus k is less than equals to x. So this is the upper bound of x. Now let's find the lower bound. So for the lower bound, the value of n minus x is negative. So I'll consider it, and solving this equation will give us minus n plus x and less than equals to k. So if we solve for x, then I'll get minus n minus k is less than equals to x is less than equals to minus x. Correct. So taking minus outside, I'll get n plus k is less than equals to x. Okay, so this is the upper bound. This is the upper bound for the question, and this is the lower bound for the question. Okay, so for the given example, n is equals to 5, n equals to 5, and k is equals to 1. The lower bound will be 5 minus 1, that is equals to 4, and the upper bound will be um, n plus k, that is equals to 6. That is why it is given here that you have to check between this range. So the question is simplified. Let's code it. I'll be writing comments on each of the steps I'll be writing. So first, define the range. Define the range of x, and that will be lower bound LB, or yeah, lower bound will be n minus k. Lower bound will be n minus k. Um, what if k is greater than n? Then the case reverse. Okay. If this is negative, then what we have to do? We have to take the absolute value of this. Okay. Now let's go for the upper bound, and upper bound will always be positive. Okay. Now we have to go till lower bound. So for I in range, for x in range, lower bound to upper bound plus 1. Okay. Now we have to apply these two conditions. So I'll take a count variable or answer variable, which is equals to 0 out now. And if absolute value of n minus x is less than equals to k, and n and x equals to 0. So these are the two conditions. If it's true, then I'll increase the value of answer, and at the end I'll return the answer. Let's submit this. Okay, there is a syntax error right over here. Okay, runtime error. What is the error? Upper bound is not defined. Okay, I wrote up. Okay, so the answer for the first is 3 here, which is not correct. And the answer for second one is 0. That is correct. But I think I'm doing some sort of mistake right over here. Let me check. Now it's 0. Okay. But it is given that okay. If n, I got the point here. If the range is getting less than 0, then what we have to do is we have to assign the lower bound as 0. Greater than equals to 0, else 0. I think this will solve our problem. No. So currently the output is 4, but the actual output is 10. Okay. Okay. Got it. In our answer, I'm currently taking answer plus equals to 1, but we have to take answer plus equals to x. And I think, yeah, it will work. So this was the question. Let me recap this. So what we were trying to do is we were trying to find out the range of the x, which is lower bound and upper bound, defined by the lower bound and upper bound. So the final range will be LB comma UB. Okay. So if the n minus k value is less than 0, then we'll assign it 0. Otherwise, we'll assign the value n minus k itself. And the upper bound will be n plus k, which I already derived right over here. So you can refer that. And then we are iterating over the range and checking for all these two conditions. If the condition is true, then we are adding it into the answer and then returning it. Let's submit this question. Okay, thousand test cases pass. So this was the solution for the question. Let's go toward the next question. I hope we'll be able to solve that question as well. Okay, valid binary strings with cost limit. Okay, so let's read the question first. You're given two integers n and k. The cost of a binary string s is defined as the sum of all indices. Okay, we are given with n and k, and the cost of a binary string s is defined as sum of the all indices I, zero based, such that s of I is equals to 1. Okay, a binary string is considered valid if it does not contain two consecutive ones. Okay. Hmm. Its cost is less than equals to k. So there are two conditions for the validation. So first we'll write the condition, and if any kind of derivation is required, we'll do it. So valid binary string condition. These are, okay, it does not contain two, one consecutively. The second condition is the cost should be less than or equals to k. So these are the two conditions. Okay. And what we have to return a list of all binary strings of the length n. Okay. What we have to return all binary strings of length n in any order. So the lexicographical order is not asked here. So we can return in any order. Okay. So let us do a dry run for example. Then only we will be able to get the intuition behind this question. So let's run for n is equals to 3 and k is equals to 1. Okay. So for n is equal to 3, the possible strings are 2 to the power n. Correct. So the total number of possible strings are 2 to the power n, which is equals to 2 to the power 3 and which is equals to 8. So there are 8 strings possible. Let's write those strings 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, and 0, 1, 1, and then 1, 0, 0, 1, 0, 1, 1, 1, 0, and the last one is 1, 1, 1. So it denotes 0, 1, 2, 3, 4, 5, 6, and 7. So these are the possible strings for n is equal to 3. Now, let's define the cost function here. The cost function will be summation of sigma all indices, summation of all indices such that s of I is equal to 1. Okay, s of I equals to 1. Got it now? So the cost for this is 0. The cost for this is 1. The cost of this is also 1. The cost of this is 2. The cost of I'll write it like this. The cost of this is 1. I'll change it here. 2, 2, and 3. Got it? So the cost is number of ones present in a binary string. And we also have to find that we have to also have to find the valid string, and valid string always contains, okay, always contains no consecutive 0. Does not contain consecutive, does not contain. Okay, nice. um okay, so this question, I'm thinking of bit manipulation, current approaches. The first thing that I'm gonna use is bit manipulation, because we have to play with bits, and the range for the given n is 12 and k is, okay, k will be the sum of n into n minus 1 upon 2, so it's nc2. Okay, k is equals to nc2. 1 is less than equals to n is less than equals to 12, so at max there can be 12 bits, and the value of k will be starting from 0 and nc2. So this is a combination of n. Okay, I'll be using bit manipulation for what? For finding the cost as well as consecutive bits. You remember the last question we solved yesterday, which came in bi-weekly contest, and there we need to return true if and only if there is exactly one consecutive bit, set bit. So the one is set bit here. Okay, so we have to return the list of strings. Okay. Mhm. Okay, the brute force approach will be, let's write it here. The brute force approach will be first finding all the strings, all the possible strings, and second is validating them, validating them, and then return only valid strings. But since our n is very large, so we can generate a lot of combination from this. So we won't be going through this approach because it will always give time limit exists error daily. Okay, let me check if I'm properly visible. Okay, one watching right now. Okay, fine. So I won't be going using this approach because it will cause time limit exceeded error. Uh, because the value of n is large and we cannot generate all the possible combinations of the string. What I'll be doing instead, I'll be going through bit manipulation technique, and I'll try to find the valid numbers first, which has these two properties plus, okay, plus I can do this in two steps. First, finding the better approach is um, to find valid numbers first, and then creating list uh, of those numbers. This is how I'm thinking right now. But the optimal approach will be uh, in a single pass, you have to build a string along with the number itself. So we can do it. Okay. So let's solve this question. I'll be going for I in range 3, range um, n, because we need only 3-bit number currently for n is equal to 3. And k will be the cost. K means there should be only uh, the cost should be there should be less than equals to k number of ones, and there should be no consecutive ones. Okay, so what we'll track previous is previous one, which is currently false, and I'll be going with the bit manipulation technique. Okay, so I'll be going from 1 to n, and then we'll check. Okay, I have to check for each numbers. So let us define the range first. And okay, let's define the range first. Define the range of numbers, which is from 0 to 2 to the power n minus 1. Correct? 2 to the power n minus 1. So for that, the lower bound will be 0, and the upper bound will be um, power of 2 comma n minus 1. And I hope this will come in, I'll typecast it. Okay, power of 2 to the power n minus 1. I think I won't be needing it anymore. This is our range, and we have to find the numbers in this range. Okay, so for each number means for x in range lower bound to upper bound plus 1. Okay, okay, I can go like this. Okay, now for each number I have to check. For each number I have to check whether the current bit is set or not. Okay, I'll take it inside. I'll take it inside and making sure that the current bit is not set. So I'm writing it false here, and I'll go inside and check if x left shift right shift I and 1, it means the bit is set. So I'll check if is previous 1. If the previous bit is set, then what to do? We have to just break this loop. Okay, because I'm not gonna uh, do it, break this loop. Else what I'll do is, else uh, I'll assign is previous 1 equals to true. Okay, so we are checking here, we are checking whether two bits are consecutive or not. Okay, so we are checking here if the two bits are consecutive or not. Now what next? If the bit is consecutive, we are not gonna pick that number, so we are breaking from here as well. And if it's not previous one, then I'll assign this as previous one. Else, in the else part, if the bit is not set, then what I'll do, I'll assign is previous 1 equals to false. So this will reassign the previous to false. Now one thing is that okay, I have I also have to calculate the cost here for each number. So the current cost is 0, and if we are getting 1, then I'm adding cost plus equals to 1. I'm adding the cost now. Okay, so we also have to check if cost is greater than k, then also we have to break. So if the two digits are, this is our base condition. If two bits are consecutive and they are set bit, or the current cost is greater than equals to k. Okay, so I'll be incrementing the cost here only. Okay, otherwise these are the two cases where we have to break, otherwise this number is valid. So if we are able to reach here, now one thing, okay, where I was, so I was trying to track whether this number is valid or not. If we are able to, okay, I'll take a flag is valid, that is equals to false, that is equal to true. But if we are going here, then is valid will be false. Okay, so now what I'll be doing is, after the loop completes, I'll check if current number is valid. If current number is valid, it means if is valid, If it's valid, then what to do? If it's valid, then we have to process it uh, to create a string, or we can directly do it. We can do it on the go, I guess. So we don't need to check if it's valid or not. I'll check current answer means str num, which is equals to a list. Okay. So what I'll be doing is I'll add it here for each number. What I'll be doing is I'll uh, by the way, how will I get to know the number? Hmm. Str underscore num dot append 1, correct? Here str num dot append what 0. Okay, in this way we are able to figure out the numbers. Now I'll check if it's valid, then I'll take a lower answer here, which is equals to a list, and I'll add it answer dot append dot join str underscore num, correct? I think uh, you're able to do it. Now what I'll do is I'll try to return the answer from here, and let's see. I have an error which is expected str and assigned something else. Okay. str underscore num equals to dot join str underscore num, and then I'll assign as str underscore num. What is the error right now? Sequence item 0, expected string instance int found. Okay. Okay, let me check. So I was able to extract this one. I was able to extract this one. Why I'm getting one more answer here? Okay. For n is equals to 1, I'll be getting 2 to the power n power of 2 comma n to the power n minus 1. Hmm. o- There's some mistake. I'm getting here one more answer. I don't know why. Why is the cost 2 here? That is the reason. No? Why is the cost 2 here? The cost of a binary string is defined as sum of all the indices I, zero based. Okay. Oh, okay. The cost equals to index I. How will I know the index I? Will it work? Yeah, I'm getting correct answer here. And I am getting correct answer here. I think I have solved this question. Okay, let's submit this and see if it's working fine or not. Okay, nice. So we were able to submit this question, and yeah, this was my approach, and I hope you liked it. I think today we'll be only solving these two questions. Laterwards, if I'm trying to solve all the four questions in some video, then we'll continue it. Till then, bye bye. See you in the next contest.